we're coming to lesson 14. We're starting to talk about stats. And this first lesson, we're just gonna walk through a lot of different problems and introduce you to what all the different graphs look like. There's not going to be a lot of work involved, so let's dive in. So data science and statistics uses vast amounts of data and tries to determine patterns between certain data points. These patterns can be displayed in a variety of graphs and charts. In this lesson, we're going to walk through these. So if you follow sports, I follow Ole Miss football, and after every game, they typically put out an infographic of all the different stats for the game and certain players they want to highlight. And that is where you're going to see a lot of the pictograph type stuff, where you have a picture instead of tally marks. You have a picture that represents a certain amount, and it lays it out just like this. So like each of these newspapers is pictures represents 10 kilograms, and so they have it marked out. And you can see on September they have half of that, which would obviously be 5. And then over here on the little students, the little picture of the person represents picture of the person represents 5 students, right? And they don't have a half person here, but you can see how everything's laid out like that. And so that's kind of where you'll see them. A dot plot or a line plot provides a quick and simple way of organizing numerical data. They are typically used for smaller data sets. In Canvas, after a midterm or a final, I'll ask it to curve a grade, and it'll give me a graph like this and ask me where do I want most of the data points to be. And so this is an example of something like that that you might see. And this is clear when you lay out the data points like this. It's really clear to see where most of my data is. And as you can see right here, you have this outlier. It's a point that is going to, like if I was going to take an average or something like that, it's going to really skew my results. And so maybe I throw this one out and redo the data to give a better idea of where all the grades are. You have your stem and leaf plot, which is similar to a dot plot. However, the number line is used vertically, and the digits are used rather than dots. In an order stem and leaf plot, the data is in order from least to greatest, given in rows. Back-to-back stem and leaf plots can be used to compare data. So, like right here, as you can see, it says 9 bar 7 represents 97. So all your tens places are right here. All your ones places are right here. And so this would be 52. There is no 60s, but then you have like 70, 72, 72, 73, 75, 76, 76, 76, 77, 78. And so that's a list of all your data points. That's very similar to this up here. It's just a different way of writing it. And then if you wanted to compare 2 classes, you would have something like this. And so if you had 100, so like right here, this is going to be 100. This is going to be a 91. But if you had like a 110 or 120, then this would be an 11 and 12, and then it would be a 0 here. Okay, so that's that. And when you get to Pearson, if you wanted to look and kind of see, turn one of these into a graph, you can kind of see that it goes up. So the graph's going to look something like that. So keep that in mind. You can just turn it on its side and kind of give you what the graph's going to look like. Again, you can see that from the dot plot too. But in a Pearson assignment, you're not necessarily going to have both of those in the same problem. So if they give you a stem and leaf plot and say, hey, what's the graph going to look like? You just turn it on its side, and it's easy to do that. Now, a frequency table is similar to a pictograph, except now we're actually using tally marks. Okay, so I do this all the time at the end of every semester at the turn-in student learning outcomes. And so I look at all the finals for my classes that have SLOs that I have to keep up with, and I see, all right, who got what right and who got what right, or who got what right and who got what wrong. And I use tally marks to help me keep track of all that. Histograms. Histograms are made by joining rectangles or bars. So this is a type of bar graph. There are specifically bar graphs, and then there's histograms, but they're both a type of bar graph. Bars are all for histogram. The bars are all the same, and the scale on a vertical axis must be uniform. The main difference between a histogram and a typical bar graph is that order matters in a histogram and does not in a bar graph. Okay, so for a bar graph, order does not matter. For a bar graph, order does not matter. Okay, and then you have, of course, you have double bar graphs where you have This one talks about ages of presidents and inauguration, later and earlier presidents. So you can see that. Some other bar graphs that you might see is this one right here, which you don't see very often, but it does show, it is something you can use. And then of course you have the stacked bar graphs, like so here. Another one you're familiar with would be circle graphs or pie charts, are used to represent categorical data. A circle graph shows how parts related to the wholes in percentages. And this particular set of data is about the Titanic and how many people survived, how many people died, and it's broken down based on which class they were in, the first class, second class, third class, or the crew. And you can see that they have percentages broken down, and you have 29.9 for the crew, survived 28.5, did that, and there's 710 in total survived, and so you can do the 202 over 710 to get 28.5 and figure out, multiply that by 360, and that would tell you, all right, how much of that circle am I going to give to that? All right, and a type of question they may ask, they have a circle graph for survival and the death. Which class fared best in terms of survival? So this would be a separate type of problem. And so you would take this data, and first thing you would do is you would add up how many people are total in the first class, second class, third class, and the crew. Well, it's going to be 325 for the first class. There's going to be a total of 285 in the second class. There's a total of 706 in the third class, and in the crew, there's a total of 885 people. Okay, so which class fared better in terms of survival? So there were 202. So for the first class, there were 202 that survived out of 325. And you would get that and turn it into a decimal. Second, there was 118 that survived out of 285. For the third class, there was 178 that survived out of 706. And for the crew, there was 212 that survived out of 885. And so if we did those calculations, we would get decimals. So the first one would give you 0.622. The second one would give you 0.414. The third one would give you 0.252. And I've already done these calculations, but you could do them in a calculator. And the second one, the last one would give you 0.24. And then to turn them into percentages, you just multiply by 100. So this would be 62.2%. This would be 41.4%. This would be 25.2%. This would simply be 24%. And so which class fared better? Well, that would be first class. They had the highest survival rate based on how many were in first class. All right, and if you saw the movie Titanic, you would understand like the first class were at the top of the boat, and then second class was in the next floor, and then third floor they got closer and closer to the bottom, and then of course the crew was like right next to the hull of the boat, working on all the machinery. So that's one way you could do that. Now, if you're observing data across multiple variables, then you want to display the data in a line graph or a scatter plot. A line graph typically shows trends in a variable over time. Multiple line graphs are used to demonstrate sets of data where comparisons may be made when the relationship between variables cannot be displayed with even a broken line using a scatter plot. Now, so for a line graph, you have the simple Santa's weight over 9 years. So if you're keeping up with the weight, hopefully it's going down, unless you're a child and you're getting older, stuff like that. And so that's one point of data. And then population over 5 states, and it's multiple lines, so they're comparing 5 states at once. And so you see how the population is increasing over time. Now, where you might see this in modern day is all these prediction markets like Kalshi or Polymarket. You'll see those there, and they every day people are putting money where they think things adding money to it, and that they change over time. But those are usually, they have 2, 3, 4, or 5 things going on at once. in the political realm, like people are already betting on who's going to be the next president on the Republican side or the Democrat side, and there's like 5 candidates or more, depending on how people are betting, and so that's an idea of multiple line graphs. Now, scatter plot, the graph to the right is a type of scatter plot. You may also notice that the graph tends to go up almost in a linear fashion. Depending on the data, we can actually use a few data points to find what is called the line of best fit, which is also called the trend line. So if I were to pick a point or two on both sides, like pick a point here, and then I could connect the dots, you could kind of see that the graph, even though it's not an exact line, it's kind of going up like this. And so that would be the line of best fit. All right, if the trend line slopes up from left to right, then there is a positive association between the data points. If the trend line slopes down from left to right, there's a negative association. And if the data is all over the place, you may not be able to find any kind of linear association. Okay, so with all these different types of graphs, all right, when do you use what? All right, so choosing the right display is not always easy. There may be more than one appropriate choice. So it really depends on what you're trying to convey. All right, so for a pictograph, you might want to use it if you're using pictures or symbols. A dot plot is used most often to show frequencies. Stem and leaf plot is used to show each value in a data set to group values in intervals. Bar graphs are used to compare numbers or data items in a grouped category. Histograms used to compare numbers of data and items typically grouped in numerical intervals. Order matters in this data depicted. Circle graph is used to show division of a whole into parts. Percentage bar, which is what we showed a while ago, as that's what this is up here. This percentage bar is that kind of thing. Used to show the division of a whole into parts. So very similar to circle graph. And honestly, of these two graphs, I would probably go for the circle graph myself instead of the percentage bar. A line graph can be used to show how data values change over time, normally used for continuous data. As I mentioned, Kalshi, Polymarket, all these different betting markets that people are using these days. Scatter plot used to show the relationship between two variables. Statistics is a useful tool, but unfortunately, some people or groups use statistics to mislead or manipulate. In this lesson, we're going to show, in this part, we're going to look at how people might deceive you. So the first way people might manipulate or try to mislead you is they embellish. All right, so we can see that the cats and the dogs are separate lines, but the dogs are way bigger. They're not comparison in size to the cat. So it can give you an alternate view of how things are shaping up. Now, you could probably overcome this by just telling you what the cat is, like what the cat means, how many cats is it representing, and the dog representing, and that could probably iron that out, even if the picture sizes are different. But if you don't have a legend at all, then size matters. Another way they could do that is axis manipulation. So on this particular set of bar graphs, this is the same data. The same set of data is used for both of these graphs. But you can see one shows it barely changing and one shows a drastic change. But look how they did it. They managed, all right, on the first one, it goes up by 10, starting at 0. But on the second one, they start at 50, and it shows a drastic decline. So it's actually like this right here. It's showing you that top of the line. And so be careful. Check your axes and see how they're doing things. Cropping. Cropping means cutting out certain parts of the image, pictures or graphs. Cropping on an axis to display a trend you wish the audience to see is a common way to mislead you using graphs. So these are the same data once again, but one of them looks at a greater period of time, and so the snippet can actually be found right here. The second graph is from here to right here. So this is the snippet that the second graph is showing. Right, and you can also see like right here, like there's a big peak right here. That could also be isolated out and show you a particular set, like a big change. And where this might be useful is in like a political campaign. If you're trying to show you're running against somebody and you're trying to show how your plan would work different or way better than the other candidates, you could snapshot a piece of data on this graph and say, hey, look how much better, based on numbers I've ran, this is how much better it could be. And so just watch out for that. Other ways that people could do this, manipulate you, is using a circle graph that doesn't add up to 100. All right, part of a whole. All right, this is percentages. They should add up to 100%. But like right here, these three percentages added together do not add up to 100%. So watch out for that. Don't just take things at face value. Dig a little deeper. All right. Although statistics presented over time, these graphs do not convey the same physiological or psychological message. All right, so the number of graduates in a community college, once again, this is the same data set. One of them starts at 130 and goes up by 10. One of them starts at 100 and goes up by 50. So it's the same span of time, but you can see that there's a big drop off in the first graph, but it kind of seems like a flat line almost in the second graph. So be careful and dig a little deeper on any graph that is shown to you. Don't just take it at face value. And if you are creating the graphs, try to be as clear as possible. Don't try to manipulate the data in order to try to sell something. All right. All right. So that's an introduction to the stats and the graphs and the way they may be, how you might use them and how they may be used against you. So that's lesson 14. I'll see you in the next lesson.